Good morning, students. So we will continue yesterday's discussion today also. That is the traditional theory of cost. Are you able to hear me? Just one of you unmute and tell me. Are you able to hear me properly?
Yes,
Yes,
ma'am.
ma'am.
Okay, fine. Thank you. All right. So what we were doing yesterday, we were studying the traditional theory of cost, and there we came across the structure or the of the different types of cards in the short run, right? We started with with the equation of the total cost, where we saw two components are broadly there. They are total fixed cost and total variable cost. Then we found out the inclusion of the items in fixed cost and variable cost. What could be the probable items? Most common items. These are the most common items in the variable cost and fixed cost. Then we tried to find out the structure of the different curves, that is the total fixed cost curve and total variable cost curve. Then adding these two and combining these two, we found out the shape of a total cost curve, right? So what was our main finding? The main finding from the looks of the curve was that the total cost curve will look similar to total variable cost curve, but it will not start from the origin, because total cost curve has also an component of total fixed cost curve, which does not start from the origin, because whatever is the number of units the company is manufacturing, there has to be certain amount of total fixed cost. That's why it will not start from the origin. Total fixed cost will remain fixed throughout the number of units of production volume. So that we found that it will be a straight line parallel to the x-axis if you plot the number of units in the x-axis. Then we found out it will be parallel. So when total cost curve you will draw, you will not start from the origin, rather you will start from the point where total fixed cost was started. Okay, and the shape of the total cost curve will look similar to total variable cost. I asked you to draw this diagram in your copy. I'll take your copy once we meet in the college. Okay. So now that we know about total fixed cost, total variable cost, and total cost that is obtained by adding this total fixed and total variable, now we will have to find out the average costs definition and the looks of those curves. Okay. So now after this, the average fixed cost is found by dividing the total fixed cost by the level of output. Simply, if we know the total fixed cost amount, you will just divide that total fixed cost by the level of output. That means number of units of the production. Whatever is the number of units, that has to be in the denominator. Okay. If you know the total fixed cost amount, you will divide that by Q or X, whatever you notify, the number of units, you will divide that total fixed cost by that number of units. So in our example, let us notify it by X. So AFC will be what? It will be TFC divided by X. Graphically, the AFC is a rectangular hyperbola showing at all its points the same magnitude, that is the level of TFC. Since it is related to TFC and the denominator is the number of units, so if you go on increasing the denominator, obviously the figure of AFC will go on decreasing, because the X is in the denominator, right? Total fixed cost is not changing, but the denominator is changing. So that means what? If the denominator is going on increasing, then AFC will go on decreasing, right? So graphically, the AFC curve will look like a rectangular hyperbola. If you remember uh, your maths classes from in your school level, you should try to Recall that the magnitude of the rectangular hyperbola was something like this, which you can see on your screen. So the graphically representation of AFC will be similar to a rectangular hyperbola, which will show at all its points the same magnitude. That means the level of AFC, TFC, because TFC is not changing. So the rectangular hyperbola curve will show the same magnitude at all its points. But since the denominator is changing, if you go mathematically, the first say the number of units is 10 units, then the AFC will be at its peak. After that it will start to decrease and it will increase. But since the TFC is same, that's why it will look something like this. It won't be a straight line. Directly straight line cannot occur. Okay, so whenever you will draw the average fixed cost curve, you will have to remember the shape of a rectangular hyperbola. Then you will plot it, and the logic will be, since the denominator is increasing continuously, but TFC is same, that's why the looks of an AFC curve will be of a rectangular hyperbola, which will show the same magnitude at all its points. The average variable cost is similarly obtained by dividing the total variable cost with the corresponding level of output. Now, you remember total variable cost curve? Now we will use the total variable cost and divide the total variable cost by the number of units, and then we will find out the average variable cost curve. Graphically, the AVC means average variable cost at each level of output is derived from the slope of a line drawn from the origin to the point on the TVC curve corresponding to the particular level of output. So how it is derived? At each level of output, it will be derived from the slope of a line drawn from the origin to the point on the TVC curve. So what does that mean? See, you will draw a line from the origin, and at each level of output, that is x1, x2, you should look at the first diagram on your screen. Diagram figure number 4.5. What is it showing? Just a moment. People are trying to join. Okay, so in see, for x1 level, x2 level, what you will have to do is you will have to draw a line from the origin, and you will draw till the point the line is touching the TVC curve. Okay, you start from the origin and will stretch the line till the point where it is touching the TVC curve. Say for example x2 level, you will start drawing, first you will draw the TVC curve, obviously, an inverted S shape. Then you will draw a line from the origin till that TVC curve. Okay, if it is asking you to go beyond this line, you will go, but you will have to go on drawing till the time it is touching the TVC curve. Okay, once you draw that, after that you will use another shape, say figure 4.6. There you will again draw x-axis and y-axis, and then you will draw those points where you had touched the TVC curves. Once you can draw a dotted line here in order to show, but don't make it quite messy. You can show it separately, the average variable cost. Then you will join all those points where you could touch the TVC curve from the origin, and simply you will draw a curve which will be having shape like this. Okay. For example, in the figure 4.5, the average variable cost at x1 is the slope of the ray OA. Understood? Say x1, look at the first diagram. Say x1, the slope of the ray OA. you're stretching the line from origin till A. So this OA, the AVC at X2, that is OB, and so on. It is clear from figure 4.5 that the slope of a ray through the origin declines continuously until the ray becomes tangent to the TVC curve at C. When you will draw these points, no, you should be very careful. Follow this rule, okay? You will stretch the line, go on stretching the line, and there should be a point where it will touch the TVC curve, obviously, but it will also be a tangent to the TVC curve. See this OC, see this OC. If you stretch the line, won't it be a tangent to TVC? It will not cross TVC. It will be a tangent to TVC. So you will draw in that fashion. First A and B will go on decreasing. In this diagram also, see, there is a little bit of mistake. See, B is above A, but this B should be down to A. That is the rule, okay? So the slope of the ray through the origin will decline continuously until the ray becomes tangent to the TVC at C. So once this tangent has occurred, then the ray or then the slope of the AVC curve will start to increase. To the right of this point, that is point C, the slope of rays through the origin starts increasing. Thus, the SAVC curve falls initially as the productivity of the variable factors increases. So this average short SAVC means short run average variable cost curve. Okay. So this short run average variable cost curve will fall initially as the productivity of the variable factor increases. Productivity of the variable factor means x1, x2, x3, these are all increasing, no? So this productivity of this variable factors, as it increases, the short run average cost curve will fall initially. Then it will reach a minimum when the plant is operated optimally with the optimal combination of variable and fixed factors. So this point C is that point which is the minimum point, and it is in this point the plant is operated optimally. That means this is the optimal combination, not minimum, not maximum, but a perfect combination of fixed and variable factors. After reaching this point, the average variable cost will start to increase. Okay. So, final outcome is the shape of the SAVC curve will be something like this one. This is like a swing, no? This is like a swing. So, you will draw a curve SAVC which will look like this. You can avoid drawing this rays, no problem, because there's a lot of criticality involved in this. You have to draw this point C at the minimum level, and that point C also has to be a tangent one to TVC. So all these things are there. If you want to avoid this, you can avoid. You can simply show the SAVC curve, which will look like a swing. Okay. I hope it is clear. If not, you can ask, okay. Then ATC. Now, what is this ATC? ATC is average total cost now. We are deriving the average curves today, okay. Yesterday, we derived the total cost, total variable cost, total fixed cost. Today, we are deriving average variable cost, average fixed cost, and finally now average total cost. So similar to finding the average variable and average fixed cost, ATC will also be derived by dividing the total cost by the number of units of production, that is X. So ATC will be equals to TC divided by X. Excuse me. Now what is TC? TC is the combination of TFC and TVC. So you write equals to TFC plus TVC whole divided by x. Now what is this? If you write it separately, it will be TFC divided by x plus TVC divided by x. Isn't it? If you take LCM and all that, so it will be TFC divided by x plus TVC divided by x. So finally, what you can write? ATC equals to AFC plus AVC, because TFC by x means AFC and TVC by x means AVC, right? So finally, you can simply write ATC equals to AFC plus AVC. Graphically, the ATC curve is derived in the same way as the short-run average variable cost. Just like the previous one, we will again draw rays, okay, from origin and try to touch the total cost curve. Remember, total cost curve will not start from the origin, but it will start from a higher level, from the point where total fixed cost had started. From that point, it will start and it will look like a inverted S shape similar to total variable cost curve. So you will first draw that total cost curve. Then you will start drawing the rays from the origin till the point they touch the total cost curve. And the point will occur where if you stretch that ray from the origin, it will look like a tangent one to total cost curve. That is the point of optimum. That means here the plant is at its optimal operation level. This is the perfect point. After this point, if you go on increasing the number of units, the short run average total cost will also start to increase. So it will also look like a swing similar to SAVC curve, but it will be at a higher level. Okay. The previous curve was a swing which has which has been used for long, so it has come down. The average total cost curve will be a perfect swing. It's a new one. The park has newly installed it, so it will be a tight swing. Okay, so that is how you will draw. Now the shape is looking somewhat like a U shape also, right? It is also a swing, but it is also looking like a U shape. So this U shape of both the AVC and the ATC reflects the law of variable proportion. What is the law of variable proportion? I'm repeating so many times and I asked you to go through it also. After a certain point, the cost starts to increase. First, initially it will decrease, but reaching a certain level of output, after that it will start to increase. So both this U-shaped curve of AVC and ATC reflects the law of variable proportion or law of eventually decreasing returns to the variable factors of production. The law, you can also mention it as law of eventually decreasing returns to the variable factors of production. That means the inputs. The marginal cost is defined as the change in total cost which results from a unit change in output. Whenever the term marginal is used, I told you to describe it as a change in that cost which will result from a unit change. That means change by only 1 unit of output. Okay. Suppose the output was 10, now the output is 11. So from 10 to 11 only, the change which is occurring in the total cost. When the change in output is occurring from 10 to 11, it is increasing by only 1 unit. Then what is the change in the total cost? That is the meaning of marginal cost. Mathematically, the marginal cost is the first derivative of the total cost function, denoting total cost by C. Now, if we denote total cost by C, not TC but C, and we denote output by X, what we can also write? This derivation, we will have to use while solving the problems. Okay, so remember, if you have done derivation in 11, 12, or in 10 also, you should just see the first order derivation, how to do it. Okay, and also second order. Because when I'll do the sum, these two will be used simultaneously. First order derivation and second order derivation. So please go through those two things. Okay. So if we denote total cost by C and output by X, we will have marginal cost equals to this del. Del indicates derivation, right? Those who had done maths, you will understand this del. This is a symbol called del, indicates derivation of C with respect to X. At the denominator, you write del X. That means whatever is the function of total cost, you will have to derive the first order derivation with respect to X. Okay, just go through it once. I will also make one simple video and upload it on doing the first order derivation when it will be needed. Okay, and you also go through your maths book, those who had maths, first order and second order derivation, only these two things. Graphically, the marginal cost is the slope of the total cost curve, which of course is the same at any point as the slope of the total variable cost. The slope of a curve at any one of its points is the slope of the tangent at that point. With an inverse S shape of the total cost and total variable cost, the marginal cost curve will be U-shaped. In the figure 4.9, that is the first figure, we observe that the slope of the tangent to the total cost curve declines gradually. This is the slope, no? These are the slopes. Del x, del c, del ax. What are this? Oh, anyways, these are the slopes that you are drawing, right? Whenever you will draw the slopes, you will find out that obviously they are first decreasing, and it will also look like an U-shaped curve. The slope of this tangent to the total cost curve will decline gradually and until it becomes parallel to the x-axis. See, if you go on drawing the tangents, that is how you find out the slope. Okay, if you have to go on drawing tangent to this curve wherever possible. Wherever you are finding a point where you can draw the tangent, you will go on drawing. Then you will find that it is increasing first. In this diagrams, it is not shown as increasing, as decreasing. Okay, when you will draw it, draw it properly so that it looks like it is decreasing first. Or you can avoid drawing this in order to avoid all the messiness and giving scope for the examiner to deduct marks. You can simply draw this one, second diagram. Okay, that will be better. But you should explain that this marginal cost curve, short run marginal cost curve, has been obtained by drawing slopes of the tangent to the total cost curve until the slope becomes parallel to the x-axis. So at a point you will find that the slope is becoming parallel to the x-axis with the slope being equal to 0 at this point and then starts rising. Accordingly, we draw the MC curve in the figure 4.10 as U-shaped. So you can simply draw this curve and then explain the derivation of it if it is asked. Okay, suppose the question comes, describe the marginal cost curve. Only then you will explain. Otherwise, not needed. It may also come that in a single graph, you show all the different curves. That is total cost, total variable cost, total fixed cost, average variable cost, average fixed cost, then marginal cost. So 7 types of curves you might be asked to draw in a single graph. Then simply will draw and explain how the slope they are looking, how the graph shape is looking. That's it. No need to explain the derivation. So this is our last paragraph for today. In summary, the traditional theory of cost postulates that in the short run, The cost curves, that is average variable cost, average total cost and marginal cost, is U-shaped, reflecting the law of variable proportions. In the short run, with a fixed plant, there is a phase of increasing productivity, that is falling unit costs, and a phase of decreasing productivity, increasing unit costs of the variable factors. This line you have to mention clearly. Once you draw all the graphs, all the curves in a single graph, suppose you are drawing, then you have to mention this summarized behavior of the traditional theory of cost. Between these two phases of planned operation, there is a single point at which unit costs are at a minimum. When this point on the short run average total cost is reached, the plant is utilized optimally. That is, with the optimal combination of fixed and variable factors. These are very vital lines. Okay, these 4 lines are quite vital. So whatever you're drawing, whatever you're showing, suppose you are asked to describe all the types of curves, whatever you will write, but at the end you will write this summary like this. That average variable, average total and marginal cost curve are like U shape, which depicts the law of variable proportion. It indicates that in the short run, with a fixed plant, there is a phase of increasing productivity. That means increasing productivity means falling unit cost. And also there will be a phase of decreasing productivity, that means increasing unit cost. Remember the U shape, first it will fall, then it will rise. So when it is falling, that means cost is falling, so productivity is increasing. And once it start to go up, U shape, right hand side it go up, no? It go up. When it is going up, it indicates decreasing productivity but increasing cost. When cost is increasing, that means entire productivity is decreasing. So that you have to indicate clearly. And between these two phases, there will be a single point. Remember that point at the lower side of the U, at the swing, the point at which the costs will be minimum, and when this point will be reached, it will be said that the plant is utilized optimally. That means the best combination of fixed and variable factors of production are being utilized. Okay, so this much for today. Tomorrow we'll discuss all these things. The relationship between average total cost and average variable cost. These diagrams are also very important. You might be asked to discuss the relationship between these curves that you will learn. Then after that we will move on to the long run cost curves. Here the envelope curves and all that will come. Okay, so we'll do it gradually tomorrow and day after tomorrow and like that. Okay, let me take the attendance. After that you will leave the class. Please respond. Abhay Sharma.
Present, ma'am.
Aditya. Alsava. Aman.
Present, ma'am.
Goyal or Sharma?
Ma'am, go ahead.
Goyal, okay. Sharma. Ananta. Ananta present? Absent. Angela. Anish. Anisha.
Present, ma'am.
Ankit. Anmol.
Yes, ma'am.
Anmol Lama. Bhavesh. Bikash.
Present,
Vishwadeep.
ma'am.
Charu.
Present, ma'am.
Chirag. Deepika. Girish. Himani.
Present, ma'am.
Jaya.
Present, ma'am.
Kashish.
Present, ma'am.
Meghna.
Present,
Mehul.
ma'am.
Parveen.
Present, ma'am.
Muskan Agarwal.
Present, ma'am. Ma'am, 21 present.
Okay. And 59. Muskan Agarwal. Neha Shanghai, Nikhil, Nishita, Nupur,
Yes, ma'am. Present, ma'am. Present, ma'am.
Nupur.
Present, ma'am.
Okay. Piyush,
Present, ma'am.
Pragati, Prageshwar, Prashant,
Present, ma'am.
Pratham, Preeti, Poonam, Ron,
Present, ma'am.
Ravi,
Present,
Rian,
ma'am.
Riyant, Ria, Rohan, Ronak, Sahil, Kshama, Srishti, Sneha, Saurabh,
Present,
Agarwal.
ma'am. Miss Saurav Sarkar, present.
Yes, Agarwal, Srishti,
Present, ma'am.
Suhana,
Present, ma'am.
Sujit,
Present, ma'am.
Suvneet,
Present, ma'am.
Swati,
Present, miss.
Swayam, Tania, Yash, Yachika, Shreya. Okay, those who are done, you can leave. Anyone having network issue and all that, just text me. Okay, fine. Then bye bye. See you
Shishi
tomorrow.
ma'am,
Yes,
Sarthak Bansal present.
Arthik Bansal.
Sarthak ma'am.
Arthak, okay. Where were you? Every day you just tell me, no, after this. Okay, Sarthak, I'll give you. Sarthak, are you there?